These are notes for pre-calculus third hour on Monday, 10/23. And we're continuing on section 2.4. And so we're going to have a few examples, and then you can have some work time and time to correct your homework if you need to do that. So our next problem, and we had just ended on Wednesday with a problem like this, but our next problem is 4B, write the following in standard form. So just a reminder, we're going to use the conjugate of the denominator. So this is 2 plus I over 2 minus I. So the conjugate of the denominator is 2 plus I. We're going to multiply by 2 plus I over 2 plus I. Make sure to put those in parentheses, and we're just going to FOIL that out. So our first terms in the numerator, it gives us 4, plus outside terms, 2I plus 2I for the inside terms, and then plus I squared. On the bottom, we get 4 minus I squared. So just a reminder then, on this top one, that I squared turns into minus 1. And this minus I squared on the bottom becomes plus 1. And then we get 4 minus 1 on the top, which is 3, plus, and then 2I plus 2I is 4I, all over 4 plus 1, which is 5. When we write that in standard form then, we get 3/5 plus 4/5 I. And then that's in the standard form A plus BI. The next section of this particular one is complex solutions of quadratic equations. I would say that you're the most familiar with because you've used that quadratic formula and put that in, put the A, B, and C values in and gotten complex answers or solutions before. So just a reminder that square root of -3 is the square root of 3I. And just a reminder, and I said this last time, that I write that as I, the square root of 3, so my I doesn't slip under that. And this is called the principal square root of -3 is the positive square root. So the thing that we want to be aware of, the principal square root of a negative number, when A is a positive real number, the principal square root of -A is defined as the square root of -A is the square root of AI. And of course, again, I'm going to write that as the square root of A, so that I don't have a problem with that I accidentally slipping under the radical as we go. So we're going to be careful of that. Then we kind of talked briefly about what happens when we multiply these complex radicals together, and it's not necessarily what we would immediately expect. So when we're working with real numbers, so when we have real numbers, we know that the square root of A times the square root of B is equal to the square root of AB. And we know that the square root of AB is equal to the square root of A times the square root of B. But when we're working with complex numbers, things are a little bit different. So for complex numbers, we have to kind of think about that I and pull that I out before we do our multiplication. So if I have the square root of -5 times the square root of -5, I have to kind of think of that as I the square root of 5 times I the square root of 5. And then when I do that, I realize that that's going to be I squared times the square root of 25. Now I can multiply that square root of 5 times square root of 5. And then that's -1 times 5. So the answer to that is -5. And that is okay, and that is correct. I am just going to point out that you must take out the I first. Must take out the I first before multiplying. Before multiplying. So I will put on here what is not okay, just to kind of let you know. This is not okay to take the square root of -5 times the square root of -5 and say that's the square root of -5 times, oops, -5. And let me write that a little bit better. The square root of -5 times -5. Oh my goodness, I don't know why I am having trouble writing that. Here, let me just rewrite the whole thing. So the square root of -5 times -5, which would appear to be the square root of 25, which is plain old 5. So that is not okay. I guarantee you need to know that. So just be careful as you go. So next, we'll go ahead a couple of slides here. This is a few problems for you to try. I'll ask that you just pause this, and then when you're ready to check your work, you can go to the next slide. So again, just take a minute, pause this, and then when you're ready to go to the next slide, you can do that. Okay, so now here are these answers to these 4 problems. I'll let you kind of check your work over. I'll slide that down a little bit so that you can see that last one. And so make sure that you're checking over that. And if you have questions, you can ask me tomorrow and I will go over that as well. Now, our next problem that we're going to look at is just solving a complex quadratic equation. So remember, this is ax squared plus bx plus c equals 0. So I'll take a minute and I'm going to write that now. 3x squared minus 2x plus 5 equals 0. That means a is equal to 3, b is equal to -2, and c is equal to 5. Of course, we know our friend, the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Wow, I just sang on the recording. So fun. And now when I put those in, the opposite of b is +2 plus or minus the square root of, I like to square b right away so that I remember that it's positive. -2 squared is 4, minus 4 times a, which is 3, times c, which is 5, and then all over 2 times a, which is 2 times 3. So then that gives me x equals 2 plus or minus the big square root. Well, when I multiply those, I get 12 times 5, which would be 60. 4 minus 60 is -56. So I'll just write that over plane 6. Now, I do want to go over and think about simplifying this radical, because we had a real radical on the last test, and some people had a little trouble simplifying that. So x equals 2 plus or minus. The perfect square factor that goes into 56 is 4. So this will be I, the square root of 56 over 6. So then that is 2 plus or minus, and then the square root of 56 is the square root of 4 times 14, and so that's 2 the square root of 14. So I'm going to call that 2 plus or minus 2i the square root of 14 all over 6. Then using kind of some factoring out that common factor. So I'm going to say x is equal to, in the numerator here, I'm going to factor out a common factor of 2, and then I'll reduce that with the denominator. So let me get rid of that yellow. And so I'm going to go 2 parentheses 1 plus or minus I the square root of 14 all over 6. My 2 and my 6 can be reduced to 1 and 3. And so then that gives me x equals 1 plus or minus I, the square root of 14, all over 3. And I want to be able to write that in standard form. I can still leave it as the plus or minus, but I'm still going to say x equals 1/3 plus or minus the square root of 14 over 3. And then I will put the I in the back when I kind of shift it so that it's kind of between the numerator and denominator. And so then my answers truly are 1/3 plus the square root of 14 over 3 and 1/3 minus the square root of 14 over 3. I have a couple problems from the homework that I'd like to put up here, as well. And there's that one. It'll be on my Yola site. And this is 61 and 63 from this section 2.4. Not only do we have to get a common denominator and then kind of simplify those, but then we'll have to do the work to make that denominator rational as we go. So I'll just rewrite these as I go. So this is 2 over 1 plus I minus 3 over 1 minus I. So the common denominator is going to be 1 plus I times 1 minus I. This one's a little more straightforward. 63 is kind of ugly, but I will go through it as well. So I'm just going to rewrite them. 2 over 1 plus I, and I'm going to multiply that one by 1 minus I, and under 1 minus I. So that'll give me a common denominator there. Minus 3 over 1 minus I, and I'm going to multiply that times 1 plus I and 1 plus I. So that I don't change the value. On this, I'm just going to write this as a single fraction then. The denominator is that 1 plus I times 1 minus I. And I'm going to just FOIL that out in my head. Those are conjugate pairs also, so that will be 1 minus I squared. On the top, I'm going to distribute and then combine like terms. Keep in mind, I have this minus in between here, so I'm going to distribute that as kind of a -3 that I'm distributing into there, so I could think of it as plus -3 as well. So when I do that, I'm going to get from the first part here 2 minus 2I, from the second part minus 3 minus 3I. Then when I get that simplified, let me kind of just go through this. I'll have 2 minus 3, -1, minus 5I over 2. When I write that in standard form, -1/2 minus 5/2 I. And so there's that problem. I think that I have these two problems on this one page. I think I'll clone this page. And then on this second one, I'll get rid of all of that writing. And then I'm just going to slide this 63 over here. And that's the one that I'll be looking at on this slide. So that just kind of gives me space, because this is kind of an ugly one. I've already said that. So for this one, I have I over 3 minus 2I. I have to multiply by my common denominator, or make my common denominator, which will be 3 minus 2I times 3 plus 8I. And so I'm just going to leave some space here, 2I over 3 plus 8I. And like I said, this one is kind of a little bit ugly. My first fraction has to be multiplied by 3 plus 8I over 3 plus 8I. So I'm not going to be as fortunate as in the last problem where I had the conjugate pairs. This one will be 3 minus 2I over 3 minus 2I. And I'll put some extra parentheses here so I can FOIL that out. On the bottom, I'm going to end up with the same denominator, so I'll just multiply that and see what that's going to be. On the top, I'm going to distribute, so I'm going to get 3I plus 8i squared there. This is a plus 2i, so I'll just distribute that 2i, and I'll get plus 6i and minus 4i squared. On the bottom, I have to just multiply these two binomials. So I'll just get rid of that yellow stuff, but then I'll multiply those. And I'll just write that out because I know it's going to take me a little bit more work. So the first term's 9, then plus 24i, and then minus 6i, and then minus 16i squared. Just to shorten up my work, and I'll just slide that down a little bit. To shorten up my work, I'm going to take that numerator where it says negative minus 4i squared and minus 16i squared, and I'm just going to multiply each of those by the negative 1, that is I squared, and I'm just going to cross those out. Oh, not with yellow though. I'll use a blue marker, and I'll say that's now going to be plus 4. And I'll cross that out and say that's now going to be plus 16. Then let me write down what I end up with oops, I missed one. There's also this plus 8i squared. I'll also make that into minus 8. So I'm going to put my numerical parts first. When I take the negative 8 plus 4, I get negative 4. And then 3i plus 6i is plus 9i on the top. On the bottom, when I combine those, the 9 and 16 is 25, and the 24i minus 6i is plus 18i. Now, that is kind of that getting a common denominator and combining like terms and all that kind of stuff. But now I have to still rationalize that denominator, get rid of that I. So now I have to multiply by the conjugate pairs. So this is where it gets kind of just not very easy to manage numbers, but we can do it. 25 minus 18i is the conjugate of the denominator. So we'll multiply by that. And then I'll just FOIL that out. I'll maybe kind of say what they are as I go. So negative 4 times 25 is negative 100. Negative 4 times negative 18i is plus 72i. And 9i times 25 is plus 225i. And then 9i times negative 18i is minus 162i squared, which I know I'll be changing after a little bit. Then my conjugate pairs, 25 times 25 is 625, and 18 times 18 is 324, so minus 324i squared. Again, I'll make that change. The minus 162i squared becomes plus 162. The minus 324i squared becomes plus 324. And then that leaves me with 62 plus 297i over 949. So then separating that out to standard form, 62 over 949 plus 297 over 949i. And I just wanted to do that one also because it was just kind of an ugly-ish seeming problem. So that is it for the notes for 2-4. Next, you're going to correct homework 2-3. Ask the teacher, Miss Eckhoff, to highlight your homework if you're done with it, and then you can show her where we keep the keys when we're done on the top of the computer there, and then you can have some work time to work on homework for 2-4 or 2-3 or any of those other ones if you're not done with them. And remember, we want a kind of quiet library-like environment so that people are able to study. So have fun using your work time, and I will see you tomorrow.